Okay, so this question here on page 51 of the David Anderson book is the one we're going to deal with in this video. So this is in the higher level section here of the solids in contact chapter, okay? So we can draw some of this information here. So the diagram of 4.3 shows the elevation of two spheres and a cone in contact with one another. Draw the elevation and plan of the solid showing all points of contact. So you can draw the cone here in elevation, you can draw the sphere in elevation, this blue sphere, okay? So we have that much drawn in elevation anyway, that's what I've done here. And I'm going to be able to draw these in plan also. So the cone, that diameter, that's my cone. And to draw my sphere then, it's the same as what we've always done. I'm going to draw the temporary sphere out here to the side, bring it down and rotate it around. I'm going to bisect this angle between the XY line and the cone. And I'm going to bring across the height of its center. It's there. Now draw back in my cone here. So this is my temporary sphere A. Bring it down to the center there of the cone in plan. Rotate it around. And bring down the center there, which is there, so rotate it a small bit more. There we go. Set my radius again on the compass. So that's A, now also found in the plan. This yellow sphere, this sphere B, okay, is a bit more difficult, okay? So, I'm going to get my red first and I'm going to play my XY line for it to stand out. So, in the question it tells us that the center of sphere B is 40 millimeters above the XY line, but I don't know the radius of the sphere just yet, okay? So what I'm going to do is I'm going to measure 40 millimeters from the center of this sphere here, so it's 65 from the XY line. So I'm going to measure my 65 from the XY line. Mark there. I'm going to draw this line straight across the page, like so. So my center of sphere B is on that yellow line somewhere. I just need to try find out the radius of that sphere. So what I'm going to do is I'm going to do a locus of points curving up in this direction here until it crosses that center line. Then I'm going to be able to use that to figure out the distance of, or the radius of my sphere. So what I'm going to do is I'm going to measure out a series of tens from the side of the cone. So I'm going to step out a series of tens. 30. And now I'm going to add on a series of tens to this radius of this sphere. So this sphere was 25. So what I'm going to do first is measure 35. I'm going to swing an arc there. And then I'm going to go parallel to the side of the cone for that first 10 millimeters I measured out from the cone, which gives me that point there. Okay, I'm going to do the exact same thing for the other points I've created. So that's there. So it's 35 plus 10 is 45. Now I'm going to be sitting next to my compass. So from the center here of that point there, I got 55. That point there. So I can now drawing that curve or that locus of points. Gonna go on up there that way. Now where this locus of points crosses the yellow line I have drawn, I'm going to join it back to sphere A, the center of sphere A, and that now from this point to where it touches sphere A is the radius of the sphere. So see the way there now, it's after touching temporary sphere A and the side of the cone perfectly. So that's B there now completed, right? That's temporary B completed. So what we're going to do now, so we have the size of our cone, the radius of our cone. I know it's on the center line of the cone, so just keep the same radius with your compass. Plant it down there. So that's B now found in the elevation. Black. That's B now, permanent position for B. Okay. Now I'm going to have to do the exact same as what I normally do. So this is my temporary sphere out to the side here. I'm going to bring it down, rotate it around, and draw it in here. So I'll bring B down, rotate it around, to the center line there. Just go back up and get my radius again of sphere B. So that's sphere B there now, completed, okay? So that's the spheres now found in plane and elevation in contact with the cone. The next part of the question asks us to get the points of contact for each within, okay? So the way we do the point of contacts is we join A and B like we have up here in our temporary spheres in elevation. So we join A and B, the centers, okay? Where they meet right there, that's a temporary point of contact, okay? Because it's not, these are only temporary spheres now, remember. But this is going to help us to find the actual point of contact in plane. So we join them, which gives us, I'll call that P, okay? So we bring P down now, rotate it around to the center line. Gives us that point right there, which is a point of contact. So that's the point of contact between B and A. So the two spheres, that's the point of contact. And to get it in elevation then, I just bring it straight across to that center line there, because the everything is resting on that center line. Straight across to there. So that's it now in elevation. So that's the point of contact between the two spheres. Okay. Now you need to get to each sphere where it's in contact with the cone. So to do that, we go back at 90 degrees to the side of the cone from the center line. Where that hits, then we can bring it down, rotate it around, and bring it straight across. Okay. So here's pink here. So I got 90 degrees to the cone. Side of the cone, so the side of the cone here, 90 degrees to the center of this sphere, to this side of the cone there. I can bring these two straight down then, right down to there, right down to there. I can rotate these around. So this is my point of contact here, point of contact here. and then I can just bring them straight across in the elevation here to that center line to find their point of contact in elevation. Just go straight across there, go straight across there, go here and here are my points of contact. Point of contact. So that's the question fully completed there now. I'm just going to draw in a few arrows here. Just try and help you follow these lines. So it comes down, down, rotates around. Same with the blue then, so the blue, they get joined. Then where that point meets here, it comes down, down, rotated around, and you bring this point straight across there. So that's the question fully completed there. As I said, page 51, higher level solids in contact.